Hello, good morning, everyone. Am I audible and my screen is visible to you? Yes. Hello, good morning. Hi. Hello, good morning, everyone. Am I audible to you and my screen is visible to you? Yes, thank you for responding. How are you today? Okay, so now let's start with our today's session. Today we are going to talk about chemical kinetics. This is very important chapter from physical chemistry. This is mostly numerical based problem. Okay, so in most of NEET exam, numericals are asked depending upon this chapter, chemical kinetics. Okay, so let's start with our session today. So chemical kinetics deals with the rate of a given chemical reaction. Okay, chemical means chemical reactions. Kinetics means what? The rate. Okay, we are going to learn about the rate of the given chemical reaction here, whether the reaction will takes place slowly, whether the reaction takes place faster. Okay, we can determine the rate of a given chemical reaction by studying the kinetics of that given reaction. So there are different things which are necessary in order to learn the chemical kinetics. So when we talk about the chemical kinetics, we think about here instantaneous rate. So what is that instantaneous rate? The rate of reaction at any particular instant during the course of a reaction. At particular instant, when the reaction is taking place at a particular place at a particular time, what will be the rate of a given reaction? That is nothing but what? Your instantaneous rate. What is average rate? So average rate depends upon the number of change in concentration of reactant or product, and the time which is taken for such a change is known as average rate. So you must be knowing the formula for rate, average rate. Average rate is equal to change in the rate of reaction with respect to time. So R2 minus R1 are what? The change of respective average rate we are calculating, right? So first rate, second rate minus first rate divided by the time required for the second to the first. Okay, this integrated rate law and linear plots of different reactions is shown here. You can see for zero order reaction also I have shown here, and for first order reaction also I have shown here the differential rate law and integrated rate law. The linear plots for these two as well as their half-lives. This chart is very important. Okay, the graph you can see here, reactant versus time, and here ln of reactant versus time is there. Okay, the slope of this is minus k, that is rate constant. The slope of this is again minus k. Okay, here the intercept is what? Reactant at initial condition. Here intercept is what? Reactant at initial condition, but ln is present there. Okay, natural logarithm. And you know half-life formula is very important. For zero order, it is concentration divided by 2k, and for first order reaction, the half-life period is independent of the concentration of the reactant. Okay, this is very important formula. Next, what is the temperature dependence of a rate of reaction? So for any chemical reaction which is occurring, if there is a rise of 10 degrees Celsius, then the rate of the reaction or the rate constant is increased by double amount. Okay, so the rate constant increases by doubled. Okay, this is very, very important. And in order to learn this temperature dependence on the rate of reaction, a very good scientist came forward, Arrhenius, and he has suggested his equation, that is K is equal to A E raised to minus EA upon RT. What is A? A is Arrhenius constant. What is K here? That is the rate constant. Okay, and EA is the activation energy, R is the gas constant, and T is the temperature. Okay, so when this equation has been simplified, first of all, the natural logarithm has been takes place. Ln K is equal to ln A minus EA by RT. Just a simple step. Okay, then instead of ln, if you put log, then what will happen? 2.303 will come into the existence, and that's why the reaction, sorry, the formula will become log K is equal to log A minus EA upon 2.303 RT. Because यहाँ पे भी 2.303 RT आएगा, यहाँ पे भी आएगा, तो पूरे इक्वेशन को we have divided by 2.303, and what will happen? ये constant जो term है वहाँ पे वो 2.303 RT आ जाएगा. This is at a particular temperature. If we carry out the reaction at two different temperature, then that time we will get two different rate constant. So what will be those? K2 and K1. Okay, so here equal to sign will be not there. Log of K2 by K1 is equal to EA upon 2.303 T2 minus T1 upon T2 into T1. This equation is also very, very important when in MCQs such type of equation also asked. Okay, so यहाँ पे K2 और K1 क्या है? These are the values of rate constant at a particular temperature with respect to T1 and T2. When you plot a graph here of log K versus 1 by T, okay, when you plot a graph of here log K versus 1 by T, what happens is that it gives us line with the slope minus EA by 2.303. So यहाँ पे we get the slope like we get the line like this, a straight line with the negative slope minus EA by R, or you can write 2.303 R. Okay, and what will be the slope, intercept of this? Log A, that is our Arrhenius constant. Okay, this will be the intercept. This will be your what? Slope of a given line. This is very, very important. Arrhenius equation, its graph. What will be the nature of the graph? What is the equation? This is a simple equation. This is the what we can say in terms of logarithmic equation. Okay, this is in terms of ln equation. All these three equations are very, very important. Next, when we talk about the rate constant, rate constant for zero order reaction, we write it like this way: K is equal to R0 minus R divided by T. Okay, rate constant for first order reaction will be like this way. You know this equation, K is equal to 2.303 upon T, log of initial concentration divided by final concentration. Okay, next rate constant, that is for first order only, but it is for gaseous phase. Okay, P is the initial pressure and 2pi minus Pt, that is a final pressure, and which is we are going to subtract from the initial pressure. So these are very, very important equation. Next, rate expression and rate constant. So the mathematical expression which particularly relates the rate of reaction, okay, and concentration of reactant is called rate law equation. What is rate law equation? It is the relationship between rate equation, okay, rate constant and the concentrations of reactant. Here you can see a simple equation. Reaction is given A plus B, A moles of A plus B moles of B reacts together to form C moles of C and D moles of D. Here ABC are stoichiometric coefficient. So what will be the rate of this given reaction? It is directly proportional to, it will be directly proportional to the number of reactants present. Okay, concentration of the reactant present with respect to their respective number of moles. So A and B are the reactant and small a and small b are their what? Number of moles. So I have directly written that. Okay, so where x and y may or may not be equal to the a and b. Okay, so यहाँ पे सिर्फ x और y लिए है, जो a और b भी होगी या फिर उनसे अलग होगी. ठीक है, तो रेट क्या होगा? ये इक्वल, ये प्रोपोर्शनलिटी साइन मैंने रिमूव कर दिया. I have written equal to sign, and when you remove the proportionality sign, you put a constant there. So that is what K, and that is nothing but the rate constant. So the rate of a reaction is related to the rate constant and the concentrations of the reactants. Okay, next, the factors which affect the rate of reaction. So there are three major factors which affect the rate of reaction. First one is the concentration, next is temperature, then the presence of catalyst. So greater the concentration of the reactant, faster will be the reaction. Please remember this. Temperature, rate of the reaction increase. Just now we have talked about the Arrhenius equation, right? If there is an increase in the temperature, the reaction becomes faster. Why reaction becomes faster? Because the molecules present there, their energy increases, and that's why as temperature increases, rate of reaction increases. Presence of catalyst. What is happening with the catalyst is present? A catalyst increases the speed of reaction without itself being consumed in the reaction. So catalyst has a positive effect in the chemical kinetics. Okay, it increases the rate of a given reaction. Next, what is molecularity and what is order? So these two are very, very important definitions. Okay, what is molecularity and what is order? So what is molecularity? It is the minimum number of molecules or atoms or ions of reactant required for an elementary reaction to occur, which is indicated by the sum of the stoichiometric coefficients of the reactant. So here, see this reaction, AA plus BB gives product. So what is the molecularity? How many number of molecules are present there? So here A moles of A are present and B moles of B are present. So just make the sum of these, you will get the molecularity. How many number of molecules are present is known as the molecularity of a reaction. So here you can see for PCl5, how many reactant molecule? One only. So molecularity will be 1. Here, how many molecules are there? H2 ka 1, I2 ka 1. So overall molecules are 2. So that's why molecularity will be 2. Right? Next, order of reaction. So what is order of reaction? So order of reaction is defined as the summation of powers of concentration terms which appear in the rate law. So this is our reaction. How we are going to write the rate? Rate is directly proportional to their concentration with respect to their moles. Okay, so what will be the order? It will be the sum of the stoichiometric coefficient which are present in the rate law. So order will be what? M plus N. Okay, order will be what? M plus N. So this is about molecularity and order of a reaction. Now here consider the unit of rate constant. So in most of the exam, what happens is you have to just remember, or you just have to calculate or find out what is the unit for rate constant. So for zero order reaction, this will be our unit. For first order reaction, this will be our unit. For second order, this is your unit. Next, this is your unit. So the trick to find out the unit for K, that is rate constant, is what? Concentration raised to 1 minus Q divided by time. Divided by 1. What is Q? It is what? Order of reaction. So this is a trick, small trick. You put here 0. What you will get? Concentration divided by time. So mole per liter is concentration divided by time in terms of second. You put 1 here, 1 minus 1, 0. Concentration, anything raised to 0 is what? 1. So your concentration term will go, the K unit will be 1 upon time, that is per second. Right? In the similar way, you can do for second order as well as nth order. Right? So this is the trick for that in order to understand the unit. Very, very important. Next, pseudo first order reaction. So what are these pseudo first order reaction? So when a given reaction takes place, okay, to the first order, when one of the reactant is taken in the excess amount. Suppose here you can see what is happening, hydrolysis of ester. Okay, this is what? Ethyl ester. Okay, ethyl ester is there. So iska hydrolysis ho raha hai in presence of H plus acid hydrolysis. What is happening here is that one of the reactant molecule is in excess amount. One of the reactant molecule is in excess amount, that is water, and we are getting acid and alcohol. Okay, so when we talk about the rate of this given reaction, it only depends upon this. Even though you are writing like this, the rate only depends upon this because one of the reactant is in what? Excess amount. So when you write the rate, you are observing that the reaction is second order. But since H2 is in excess amount, okay, the rate doesn't depends upon the amount of H2O. So that's why when you write the rate now, what will happen? It is looking like a first order reaction. When you will write the rate now, it is looking like a K and only one reactant molecule is there. So that's why this will be what? First order reaction. So when the reaction in which molecularity is 2, molecularity is 2, since 2 molecules are present here, but order is 1, okay, then such a reaction is known as pseudo first order reaction. Then such a reaction is known as pseudo first order reaction. But please remember here what is happening. One of the reactant is in the excess amount. That's why Okay, one of the reactant molecule was in excess amount. That's why here the rate was different. Actual rate is what only depends upon the concentration of ester. It doesn't depends upon the concentration of water. Any doubt in this? Okay, now let's talk about the next point. Okay, let's talk about the next point. Effect of a catalyst on the rate of reaction. So what does the catalyst affects a given rate of reaction? So here you can see a diagram. Okay, what you can see here, reactant is giving us a product. Okay, the first curve is reaction path without the catalyst, and the second curve is with the catalyst. Okay, what is happening here? The energy of activation, this energy of activation, and this is the energy of activation. So without the catalyst, the difference is large. Okay, the energy of activation is very, very large. But with the catalyst, the energy of activation is low. Okay, the energy of activation is low. So when the catalyst is present, now it provides us the alternate path by reducing the activation energy. And hence, the activation energy decreases. This lowers the potential energy barrier of a given curve. Okay, and it does not alter anything like Gibbs free energy or delta G or delta H of a given reaction. Okay, the reaction takes place spontaneously, but it does not catalyze non-spontaneous reaction. Here, catalyst is used, and due to which the forward reaction becomes faster. Okay, as well as here the backward reaction becomes faster. Okay, so this is what, when catalyst is present, if reaction is taking place, let's see, it catalyzes the forward as well as backward reaction to the same extent. Means अगर catalyst forward reaction fast कर रहा है, ठीक है, catalyst के presence के वजह से, और अगर backward reaction में आपने catalyst डाल दिया, वो backward reaction भी क्या करेगा, faster कर देगा. ठीक है, so वो क्या करता है? What is the use of catalyst? It decreases, it provides us the alternate pathway as well as it decreases the activation energy for a given reaction. एक्टिवेशन एनर्जी कम हो गई, कम एनर्जी देनी पड़ी, मतलब क्या हो गया, वहां पे रिएक्शन का रेट बढ़ गया. ठीक है, so what is the effect of catalyst? It affects the activation energy for a given reaction. Next, collision theory. So this is very, very important theory, how the molecules actually react together in a given reaction. So this theory is for chemical reaction which put forwards certain points. Here it says that if two molecules react together, there must be some collision between them. Okay, they must collide together. When the molecules are colliding together, they may be having certain minimum amount of energy which they are possessing. Okay, so the minimum energy which the molecules should possess so that their mutual collision result into a chemical reaction, that is known as threshold energy. So all the molecules which are colliding with each other, they must have certain amount of minimum energy, at least they should possess, in order to collide with each other, and that energy is known as the threshold energy. Okay, effective collision means what? Even though the molecules are colliding with each other, what happens is that not every collision responsible for occurring of a reaction. So here what happens is that only such collisions which result into the formation of product. So molecules are colliding with each other, and after collision, what is going to form? Products are going to form. So sometimes products form, sometimes products doesn't form. So the collisions which result into the product are known as the effective collisions. Okay, please remember this. What is the meaning of effective collision? Those collisions which result only in the formation of product are known as the effective collision. So when these molecules are colliding with each other, they should have a certain collision frequency to that. So what is this collision frequency? The number of collision that takes place per second per unit volume of a reaction mixture is known as collision frequency. So consider this simple reaction when A molecule and B molecule collide together to give us a product. The rate of this reaction will be what? Like this way. So ZAB into e raised to minus AA by RT. And what is here ZAB? It represents the collision frequency for reactant molecules A and B. Okay. And what does this factor responsible? Minus EA by RT, e raised to minus EA by RT, that represents the fraction of molecules with energies equal to or greater than EA. EA means what? Our activation energy. Okay, so to account for this effective collision, there is one more factor P is present, that is called the probability or steric factor. Okay, probability or steric factor, it takes into account the fact in a collision molecules must be properly oriented. So in order to have the perfect collisions, the molecules should be perfectly aligned. Then and then only they will react together, and such a collisions will result us into the reaction. So that's why a P factor has been introduced, which is known as a steric factor or probability factor, and our equation becomes like this way. Rate equation becomes like this way. Okay, so the two factors has been introduced here. So thus in this collision theory, activation energy and proper orientation of the molecules together, they determine the criteria for an effective collision, and hence the rate of chemical reaction is also we can determine. Okay, we can also determine. So these are the two main factors. Okay, ZAB, that is collision frequency, and what our steric factor or probability factor. So these are the very, very important things we are going to consider in collision theory. Remember threshold energy, effective collision, and collision frequency. This is collision frequency and this is probability or steric factor. So all about chemical kinetics we have revised right now. Now let's try to solve some problems depending upon the chemical kinetics, the previous year question. So first question here you can see is, an increase in the concentration of the reactants of reaction leads to change in activation energy, rate of reaction, threshold energy, collision frequency. So here what is happening? Increase in concentration of reactant of a reaction. Okay, increase in concentration of reactants of reaction. They leads to increase in activation energy, threshold energy, rate of reaction, or collision frequency. So what will increase here? So higher the concentration of reactant molecule, what will be the higher? Higher concentration of reactant molecule, collisions will be what? More probability of collisions. More probability of collisions that is going to take place between the atoms. So that's why here what will be more? It will be what? Collision frequency will be what? More. Okay. So as collision frequency is directly proportional to the number of reacting molecules or atoms present. So as the concentration increases, the number of reacting molecules or atoms are going to increase. So higher the concentration of reactant, higher will be the probability of collision and the collision frequency. So our correct answer is what? D. Okay, any doubt in this? Okay, next problem. The rate constant for a first order reaction is, so we have given the rate constant, that is K value. Okay, and what we have to determine the time required to produce 2 gram of reactant to 0.2 gram each. So here time is we have to calculate. So our formula is 2.303 divided by T log of initial concentration, that is R naught, divided by what? Final concentration. Okay, so just put all these values. Okay, we have given K ka value, we have given the initial concentration, time required to reduce 2 gram to 0.2 gram. So 2 to 0.2 has been the difference. Okay, so solve this equation, you will get the time. Here I have solved this. Okay, यहाँ पे 2 put करो, यहाँ पे 0.2 put करो, यहाँ पे 2 put करो, यहाँ पे 0.2 put करो. ठीक है, टाइम क्या है दिया हुआ आप लोगों को, आपको टाइम निकालना है, तो ये इक्वेशन रीअरेंज कर लो. 2.303 डिवाइडेड बाय k log of 2 upon 0.2. Right? Yes, any doubt? Calculate this, you will get the answer C, 500 second. Very, very easy. See, NEET 2020 में आया है, easy problem. Equation याद रखना है, ये important equation rate constant के लिए. यहाँ पे हमको अभी क्या दिया था? Rate constant दिया हुआ था, time निकालने को कहा था. Converse can be asked. Okay, next. For a reaction, activation energy EA and the rate constant at 400 Kelvin is. So we have given here activation energy. Okay, and we need to find out the rate constant at 400 Kelvin. So यहाँ पे दो टेम्परेचर को हमको रेट दिया हुआ है. एक टेम्परेचर है 200 के लिए हमको दिया हुआ है K, और K2 जो है that is for 400 Kelvin we need to find out. Okay, we need to find out this. We have given 1K. So the formula for this will be what? Log of K2. We need to use here Arrhenius equation. That is log of K2 by K1 is equal to EA upon 2.303 R, right? Into the bracket T2 minus T1 upon T1 into T2. So put all this value, you will get K1 ka value. Okay, any doubt in this? Should I solve this? You will be able to solve this, right? Or should I solve this? So let's put the value of K2. We need to find out K1 का value क्या है 1.6 into 10 raised to 6. Okay, solve this, put all the values. What you will get? You will get the answer K2 is equal to what? 1.6 into 10 raised to minus 6. Okay, 1.6 into 10 raised to minus 6. So that's it. Next problem. If the rate constant for a first order reaction is K. If the rate constant for a first order reaction is K, 99, the time required for the completion of 99% of the reaction is. So यहाँ पे हमको बोला है कि reaction कितनी complete हो रही है? 99% complete हो रही है. ठीक है? So for first order reaction, what is the formula? T is equal to 2.303. Right? Same equation हमको use करना है first order का. K log of initial concentration divided by A minus X. तो इनिशियली कितना परसेंटेज है? 100%. उसमें से कितनी कंप्लीट हुई रिएक्शन? 99%. ठीक है, तो हम लोग क्या करेंगे, यहाँ पे लिखेंगे 2.303 डिवाइडेड बाय के लॉग ऑफ 100 डिवाइडेड बाय 100 माइनस 99% कंप्लीट हुआ है ना, इसलिए. तो सॉल्व करो इसको, आपको मिल जाएगा रेट कांस्टेंट. ओके, रेट कांस्टेंट फॉर फर्स्ट ऑर्डर रिएक्शन इज के दिया हुआ है. ठीक है, इन टर्म्स ऑफ के हमको निकालना है. तो सॉल्व करो इसको, आपको क्या मिलेगा? 2.303 डिवाइडेड बाय के log of 100 divided by 100 minus 99. How much it will be? It will be what? 1, right? Any doubt in that? Okay, so it will be equal to 2.303 divided by k log of 10 raised to 2. Solve करो इसको, 2 into log 10. ठीक है, तो यहाँ पे आ जाएगा 2.303 divided by k 2. log 10 क्या होता है? 1. तो ये क्या हो गया? 2 into 2.303 divided by k. तो 2 into 2.303 कितना हो जाएगा? 4.606. So what will be the correct answer here? D will be our correct answer. Okay, 4.606 divided by K will be our correct answer. Any doubt in this? Use this formula. First order rate constant. Okay. Next, first order reaction has rate constant of 2.303. Okay. Time required for 40 gram of this reactant to reduce to 10 gram will be. तो यहाँ पे हमको टाइम निकालना है, इक्वेशन सेम यूज करना है. K is equal to 2.303 divided by T log to the base 10 of initial concentration divided by final concentration. 40 by 10 कर लो, यहाँ पे 40 by 10. हमको क्या निकालना है? टाइम निकालना है. आपको K दिया हुआ है, ये रीअरेंज कर लो, यहाँ पे K डालो, यहाँ पे T डालो. ओके, सिंपल. Solve करो, you will get the answer 602 seconds. Yes, any doubt in this? Are you understanding this, right? Simple formula use करना है, अलग converse हो रहा है. For the reaction, N2 plus 3H2 gives ammonia. What we have to calculate here? The correct option is, तो यहाँ पे हमको find out करना है what will be the correct option. So A, B, C, D. So this is what the rate of a given reaction. So here rate for given reaction, that is N2 plus H2 gives to ammonia. तो यहाँ पे rate क्या होगा? For reactant we write rate in terms of negative because reactant concentration is going on decreases. So change in the reactant of nitrogen with respect to change in the time, okay, that will be equal to, वहां पे कुछ भी नंबर ऑफ मोल्स नहीं थे इसलिए हम लोगों ने डायरेक्टली ऐसे लिख लिए. लेकिन हाइड्रोजन के लिए क्या नंबर ऑफ मोल्स दिए हुए कितने? 1/3. बट इट इज आल्सो रिएक्टेंट, सो इट विल बी माइनस चेंज इन द concentration of H2 with respect to change in concentration of time. Not concentration of time, it's change in the time. Okay, so for product, since product concentration goes on increases, okay, D option. Yeah, since product concentration goes on increases, what will happen? We will write plus for that. Okay, change in the concentration of ammonia with respect to change in time. So rearrange this equation. What you will get is विल गेट ABCD में से कौन सा ऑप्शन आ रहा है? यस, तो your option is what? D. Very good, Lakshmi. Okay, very good. जिन्होंने रिप्लाई किया है, very very good. Okay, so your option is our D. Option D. Okay, any doubt? Yes. Okay, we'll move on to the next question. ये rearrange करके दिखाओ कि आपको समझ में आ गई बात. ठीक है, so this is equal to this. That is our option D. Is our option D. Okay. Yeah, next problem. Okay, I have written here. Yeah, next. The correct difference between first and second order reaction is that. So यहाँ पे we have to talk about first order and second order. Okay, first order and second order का difference. First order and second order. Which of the following statement is correct? Correct difference. The rate of first order reaction does not depend on reactant concentrations. The rate of a second order reaction does depend on reactant concentrations. Okay. Next, the half-life of first order reaction. Is this true or false? Yes, true or false? Next, the half-life of first order reaction does not depend on A naught, that is initial concentration. The half-life of second order reaction does depends upon A naught. So you know, for first order reaction, the half-life period equation is 0.693 upon K. 0.693 upon K. So here no initial concentration is present. So that's why this is what? Correct statement. Okay. But for second order reaction, the T half is what? For second order reaction, the T half is 1 upon K into A naught. This is the half-life period for second order reaction. So this is the correct statement, option B. Third statement, read kar lo, first order reaction can be catalyzed, a second order reaction cannot be catalyzed. This is not true. You can catalyze any kind of reaction. The rate of first order reaction does depend upon the reactant concentration. The rate of second order reaction does not. That is also not correct. It depends upon the square of the concentration. Okay. This is not correct. This is not correct. Option B is correct. Any doubt? See, very simple question has been asked. Okay. Theoretical था थोड़ा, लेकिन बहुत ही simple था. Okay. ठीक है. Independent of initial concentration, it depends upon initial concentration. Very good. Now move on to the next question. When initial concentration of reactant is doubled, okay, so यहाँ पे क्या हो गया? Initial concentration double किया है. Half-life period for zero order reaction is. So what is the formula for half-life period of zero order reaction? T half for zero order reaction is equal to initial concentration of a reactant molecule divided by 2 into rate constant. So what has been happen here? Initial concentration of reactant is double. So whatever the initial concentration was there, it has been double. So what will happen to the T half? A अगर double किया, तो T half क्या होगा? It is directly proportional to the initial concentration, right? So ये double किया, तो T half भी क्या होगा? Double हो जाएगा. This will be again become double because they are directly related to each other, and that's why here our answer will be what? B. It will get double. Any doubt? Yes, any doubts? Okay, next problem. Mechanism of hypothetical reaction. So here we have given a one hypothetical reaction. X2 plus Y2 gives 2 times of XY is given below. So यहाँ पे हमको एक mechanism दिया है. एक reaction is fast, second reaction is slow, next reaction is fast. The overall order of reaction will be. So you must remember here that whenever a reaction is given to us, okay, like this way. So let's solve this problem. See here, the note for this reaction is correct reaction given in the question is like this way. Sorry. X2, X plus X, X plus Y2 is the fast step. This is the slow step. Okay. Whenever we talk about the rate of reaction, na, slow step, whenever present in a given reaction, that will be our rate determining step. Slow step जो भी होगा ना, वो हमारा क्या हो जाएगा? रेट डिटरमाइनिंग स्टेप हो जाएगा. उससे हम लोग रेट निकालेंगे. तो यहाँ पे स्लो स्टेप कौन सा है? ये स्लो स्टेप है, सेकंड वाला. तो यहाँ पे रेट हमारा क्या हो जाएगा? रेट जो हो जाएगा वहां पे जो कॉन्सेंट्रेशन प्रेजेंट है उसके ऊपर डिपेंड करेगा. So rate is directly proportional to concentration of X into concentration of Y2. So remove this proportionality sign with the rate constant, and you will get the rate like this way. Okay, so see this rate. Okay, what you can see? Yes. Okay, so this is our rate. Okay, I have given equation 1 to that. So here for this reaction, equilibrium constant for first fast reaction is what? Fast reaction है, उसके लिए equilibrium constant कैसे आएगा? x2, ये हो गया x2, इसका square हो गया x का square divided by x2. Okay, so what is the value of x here? So x is equal to like this way, under root of k into x2. So put this value into the equation 1, that is this equation, x का value put कर दो, आपको rate मिल जाएगा. Rate is equal to k, okay, into the bracket k into x2. This k is what? Equilibrium constant. This is what? Equilibrium constant. Okay, you will get k dash x2 raised to 1/2 and y2. ठीक है, एक जो x था वो कम हो गया, वो क्या हो गया? कम हो गया. यहाँ पे क्या किया मैंने? k into k. ठीक है, मैंने क्या किया? x का वैल्यू पुट किया ना, ये जो था k डैश इंटू अंडर रूट ऑफ k इंटू अंडर रूट ऑफ k, इसको मैंने बोल दिया k डैश. बचा क्या मेरे पास? अंडर रूट ऑफ x, यहाँ पे हो गया y2. तो ये इसको मैंने क्या किया? x रेस टू हाफ लिख दिया, और y2 रेस टू क्या है? y2 का कॉन्सेंट्रेशन के ऊपर क्या है? 1 टर्म है. ठीक है, दैट इज ओनली 1 टर्म. ओके, y2 रेस टू 1. So make the sum of both 1/2 plus 1. What will be the answer? It will be what? 3/2. That is what? 1.5. Yes, any doubt? Yeah. So here, what will be the rate of overall reaction? Rate will be what? 1.5. Okay. Understood? Okay. Next problem. First order reaction has a specific rate of, हमको रेट दिया हुआ है, how much time will it take for 20 gram to reduce to 5 gram. तो first of all आपको पता है अभी इक्वेशन कौन सा है? Tell me the answer. ABCD. Put all the values in the equation. K is equal to 2.303 divided by T log of initial concentration to the final concentration. Put the values. Tell me the answer. 20 डालो यहाँ पे 5 डालो. ठीक है, टाइम दिया हुआ है 10⁻². टाइम दिया हुआ है, नहीं टाइम निकालना है. के दिया हुआ है, तो यहाँ पे खोटी, यहाँ पे डालो के. Put all those value, you will get the answer. What will be the answer here? Yes, 138.6. That is A answer. Next, the decomposition of phosphine on tungsten. Okay, the decomposition of phosphine on tungsten at low pressure is first order reaction. Okay, it is because, so decomposition of phosphine is what? First order reaction. So why this is happening? The reason we have asked, the rate is proportional to the surface coverage. Rate is inversely proportional to the surface coverage. Rate is independent of the surface coverage, and rate of decomposition is very, very low. So here, what is the answer? So do you have any guesses or any answers? Yes. Okay, I will tell you. Next, so at lower pressure, what happens is rate is proportional to the surface coverage and is of first order. While at higher pressure, what happens? It follows zero order kinetics due to complete coverage of surface area. Okay, due to complete coverage of surface area. So please remember, at lower pressure, the rate will be what? It will be proportional to the surface coverage, and that's why it will be first order reaction. So your answer will be option A. Any doubt? Second order hota, so it will be independent. Okay. Next, the rate of first order reaction, यहाँ पे rate दिया हुआ है, time दिया हुआ है, concentration दिया हुआ है, 20 seconds के बाद half life period कितना होगा, ऐसे हम लोगों को पूछा है. So what will be the half life here? Solve the problem for first order reaction. What is half life period? T half is equal to 0.693 into K. So पहले information से आपको निकालना है K का value 2.303 divided by T log of initial rate, initial concentration divided by final concentration. ओके तो यहाँ पे आप लोगों को क्या दिया हुआ है, रेट ऑफ फर्स्ट ऑर्डर रिएक्शन इज 0.04 एट 10 सेकेंड एंड 0.03 एट व्हाट 20 सेकेंड। तो यहाँ पे हमको दो टाइम दिए 30 और 20, तो यहाँ पे हम दो रेट लेंगे, रेट 1 और इसका आ जाएगा रेट 2। ठीक है, इन एंड आउट। तो यहाँ पे हम लोग डाल देंगे 2.303, T2 क्या है हमारा, यस 30 और 20 दैट इज 20 माइनस 10, यहाँ पे आ जाएगा लॉग, रेट क्या है 0.04 divided by 0.03. Solve this, you will get the value of k. As soon as you will get the value of k, put this value into T half, 0.693 divided by k. Since this reaction is first order reaction, calculate everything, you will get the answer of T half. सेम फॉर्मूला यूज करके दो टाइम दिए थे और दो रेट दिए थे, तो मैंने इस तरह से ये प्रॉब्लम को सॉल्व किया है। ओके, एनी डाउट? या वेरी गुड। नेक्स्ट our answer will be what, option C. Solve this. ये बहुत न्यूमेरिकल क्वेश्चन ही आते हैं इस चैप्टर पे, इसलिए मैंने आपको बताया कि सॉल्वेशन आपका बहुत अच्छा होना चाहिए। ओके, नेक्स्ट क्वेश्चन, द एडिशन ऑफ कैटलिस्ट during a chemical reaction alters which of the following quantities? So what does changes when you put the catalyst? The catalyst provides alternate path to the reaction, and when it provides alternate path, it decreases the activation energy, right? It lowers the activation energy. So our answer will be option B. Next problem, the rate constant for a given reaction A to B is this much. If the concentration of A is 5 molar, then concentration of B after 20 minutes is. तो यहाँ पे भी हमको इक्वेशन यूज करना है। सो दिस रिएक्शन इज व्हाट, विच टाइप ऑफ रिएक्शन, फर्स्ट ऑर्डर रिएक्शन और जीरो ऑर्डर रिएक्शन? yes, how you can determine that whether this reaction is first order or zero order? So observe the unit of rate constant. Okay, zero. Yes, very good. So this reaction is zero order reaction. Why? Observe the unit of rate constant, it is mole per liter per second. So that's why this reaction is zero order. So for this reaction we need to calculate what concentration diya hua hai, we need to calculate about the concentration at 20 minutes. So what will be the concentration at 20 minutes? Multiply rate constant with the time, you will get the concentration 0.72 molar. Any doubt in this? Okay, let's move on to the next problem. Right? Concentration of B after 20 minutes is, concentration of A diya hua tha. Okay, next. The activation energy of a reaction can be determined from the slope of which of the following graph? We have talked about this. कौन सा ग्राफ होता है वो? ln k वर्सेस t, राइट? ln k वर्सेस 1/t ग्राफ आता है इस तरह से, इसका स्लोप होता है -EA/r और इसका इंटरसेप्ट होता है ln a। ठीक है, सो क्या हो गया आंसर? ln k वर्सेस 1/t ln t। ठीक है, ABCD में से कौन सा होगा ऑप्शन? या वेरी गुड, ए आंसर होगा। और ये हम लोगों ने देखा हुआ ये बेसिकली। ठीक है, नेक्स्ट, व्हेन इनिशियल कंसंट्रेशन ऑफ रिएक्टेंट इज डबल्ड इन अ रिएक्शन, या यहाँ पे क्या हुआ है, इनिशियल कंसंट्रेशन डबल किया है, इट्स हाफ लाइफ पीरियड इज नॉट अफेक्टेड, द ऑर्डर ऑफ द रिएक्शन इज, हाफ लाइफ पीरियड अफेक्ट ही नहीं हो रहा है, तो कौन सा ऑर्डर होगा ये रिएक्शन का? फर्स्ट ऑर्डर, सेकंड ऑर्डर, जीरो ऑर्डर? किस पे होता है डिपेंड, किस पे होता है इंडिपेंडेंट? टी हाफ इज इंडिपेंडेंट ऑफ इनिशियल कॉन्सेंट्रेशन। किसमें होता है? फर्स्ट ऑर्डर में, जीरो ऑर्डर में या सेकंड ऑर्डर में? सेकंड ऑर्डर मोर देन जीरो बट लेस देन फर्स्ट, जीरो या फर्स्ट? बोलो, वेरी सिंपल। यस, द रिएक्शन विल बी द फर्स्ट ऑर्डर रिएक्शन, क्योंकि इसका टी हाफ क्या होता है 0.693 डिवाइडेड बाय के, इट इज इंडिपेंडेंट ऑफ इनिशियल कॉन्सेंट्रेशन। ओके, please remember this, very important. Okay, next, for a reaction between A and B, okay, the order with respect to A is 2 and the order with respect to B is 3. The concentration of both A and B are doubled, then the rate will increase by how much factor? तो यहाँ पे हम लोगों को A और B का रिएक्शन दिया हुआ है, ठीक है, A और B रिएक्ट हो रहे हैं, तो इसका रेट और हमको प्रोडक्ट मिल रहा है। इसका रेट हम लोग कैसे लिखेंगे? रेट इज डायरेक्टली प्रोपोर्शनल टू कॉन्सेंट्रेशन ऑफ ए इनटू कॉन्सेंट्रेशन ऑफ बी, और प्रोपोर्शनलिटी साइन हम लोग चेंज करेंगे के साथ। ठीक है, तो रेट ये हो गया हमारा। ठीक है, तो पहली बार रेट क्या है, पहला रेट क्या है हमारा, a is 2 एंड ऑर्डर विद रिस्पेक्ट टू b is 3। तो a का क्या है, स्क्वायर है, और b का क्या है, क्यूब है, ऑर्डर। ठीक है, अब क्या बोला है, अगर हम लोगों ने कॉन्सेंट्रेशन डबल किया, सेकेंड टाइम में मैंने क्या किया, कॉन्सेंट्रेशन ऑफ बोथ ए एंड बी आर डबल, सो के यहाँ पे आएगा 2a का स्क्वायर और 2b भी क्या हो गया, डबल हो गया ना, b का भी कॉन्सेंट्रेशन डबल कर दिया। अब ये जो रेट कांस्टेंट है ये कितना बदलेगा, तो के 2 का स्क्वायर 2 का क्यूब इंटू कॉन्सेंट्रेशन ऑफ ए का स्क्वायर और यहाँ पे बी का क्यूब। ओके, तो विथ रिस्पेक्ट टू रेट 1, रेट 2 कितना बदला, 2 का 2 raised to 5, हाउ मच विल इट बी, 2 raised to 5, 2 raised to 5 मतलब कितना, 12 16 32 10, हाउ मच, it will be what, 32. Okay, it will be what, 32. So our answer will be C, option C. Do you get that? Yes. Next problem, what is the activation energy for a reaction if its rate doubles when the temperature is raised? यहाँ पे टेम्परेचर हम लोगों ने चेंज किया। ठीक है, पिछले प्रॉब्लम में हम लोगों को कॉन्सेंट्रेशन चेंज करके दिया था और हमको रेट पूछा था, यहाँ पे हम लोगों ने टेम्परेचर चेंज किया है। What will be the activation energy for this given reaction? So our formula in order to calculate the activation energy is by using what, Arrhenius equation. So log of K2 by K1, okay, log of K2 by K1 हमारा formula है is equal to energy of activation divided by 2.303 R. यहाँ पे टेम्परेचर से हमारे T2 minus T1 divided by T2 into T1. So use this formula and find out the energy of activation. Okay, so here I have calculated that what is given, what is the activation energy if its rate doubles, rate क्या हो गया, डबल हो गया, T2 is equal to 2K1, टेम्परेचर दिया हुआ है 20 से क्या हो गया, 35 हो गया, उसको 273 ऐड कर दिया, केल्विन में हम लोगों को दो टेम्परेचर मिल गए। आर का वैल्यू जूल पर मोल पर केल्विन में आपको पता है 8.314 है। ठीक है, तो पहले से दूसरा रेट क्या हो रहा है, डबल हो रहा है, तो यहाँ पे क्या आ जाएगा, log 2। ठीक है, 2 is equal to EA, यहाँ पे वैसे के वैसे आ गया 2.303 into 8.314, 1 upon T1 that is 293 minus 1 upon T2 that is 308। ये थोड़ा अलाइनमेंट ये हो गया, बिगड़ गया, लेकिन आप ये देखो यहाँ पे कैसे होगा, log 2 is equal to EA upon 2.303 into 8.314, ओके, into 1 upon T1 क्या है 298 माइनस हमारा T2 क्या है 308। ठीक है, 20 डिग्री और 35 डिग्री डाल दिया है, आप इसको कैलकुलेट करो, आपको ये की वैल्यू मिल जाएगी, दैट इज दिस मच। ये अगर प्रॉब्लम मैंने अभी सॉल्व किया तो हमारे इससे टाइम निकल जाएगा। सॉल्व दिस एंड यू विल गेट द आंसर 34.7 डिग्री सेल्सियस, सॉरी किलो जूल पर मोल। जूल में आंसर मिलेगा, जूल को कन्वर्ट करो किलो जूल में, देखो आंसर देखो, हाँ ऑप्शन में क्या दिया हुआ है, यहाँ पे आर का वैल्यू दिया हुआ है। नेक्स्ट, इन अ रिएक्शन A plus B gives product, rate is doubled when the concentration of B is doubled and rate increases by factor of 8 when the concentration of both the reactants are doubled, then the rate law will be। यहाँ पे हमको सिंपली रेट लॉ पूछा है, क्या होगा अगर हमारे कॉन्सेंट्रेशन इस तरह से बदल रहे होंगे तो शुरुआत में तो हमारा A देखो और B देखो क्या है, सिंपल है, और हमारा रेट भी क्या है, सिंपल है, तो A plus B is rate। ओके, A plus B, सॉरी A और B का क्या है, A B कॉन्सेंट्रेशन और रेट, जब X था Y था तब रेट क्या था, R था। As soon as you double the rate ना, what is happening, see here I have shown X था, Y था, R था। ठीक है, X था, Y था और R था। If rate is double when the concentration of B is double, rate double होता है जब B का concentration double होता है, and rate increases by factor of 8, और rate 8 से increase होगा जब आप concentration of both the reactant double कर रहे होंगे। So what will be the rate law? Rate law will be, we don't know the rate of the reaction ना, so I will write A plus B. So from given reaction दो इक्वेशन हमको मिलेंगे, x raised to a y raised to b is equal to r and x raised to a to y raised to b is equal to 2r. Dividing equation 5 by 6 you will get that it is what, b is equal to what, 1. So put this value into the equation 1, okay, and you will get the answer 2xa 2yb is equal to 8r. Put the value of b here. You will get 2 raised to 2, that is a is 2. So what is happening? The rate will be what? A is equal to 2 and b is equal to 1. Okay, this is interesting problem. अलग टाइप से प्रॉब्लम था, इसलिए मैंने इसको लिया है. यहाँ पे एक को डबल किया तो रेट डबल हो रहा था, दोनों के अगर डबल किए तो रेट 8 टाइम्स बढ़ रहा है. ठीक है, तो इस तरह से इक्वेशन फॉर्म करके हम लोगों ने आंसर यहाँ पे फाइंड आउट किया है. समझ में आया आंसर? एनी डाउट? ओके, नेक्स्ट प्रॉब्लम. जीरो ऑर्डर रिएक्शन दिया है, इस पे हमको 10 डिग्री सेल्सियस का टेम्परेचर का राइज हो रहा है. द रेट इज बिकमिंग डबल. इफ द टेम्परेचर इज इंक्रीज फ्रॉम 10 to 100, द रेट ऑफ द रिएक्शन विल बिकम. सो यहाँ पे अगर 10 डिग्री राइज हुआ है तो रेट क्या हो रहा है? डबल हो रहा है. By 10 degree rise only, rate is becoming double. So what will happen if temperature increases from 10 to 100 degrees Celsius? So see here, very simple calculation. 100 divided by 10. So that is 100 minus 10 divided by 10. So it will be what? 2 raised to n. ठीक है, डबल हो रहा था ना, इसलिए तो कितना इंक्रीज होगा हमारा रेट? 512 टाइम्स रेट इंक्रीज होगा. ठीक है, 10 डिग्री का राइज होने के बाद 2 टाइम्स बढ़ रहा था, तो इतना डिफरेंस होने के बाद कितना बढ़ेगा? इतना बढ़ेगा. ओके, सी हाउ यू हैव टू टैकल द प्रॉब्लम. हाँ, एनी डाउट? नेक्स्ट, 60% of first order reaction was completed in 60 minutes. 50% of the same reaction would be completed in approximately how much time? 45 minutes, 60 minutes, 40 minutes, 50 minutes. Yes, 60% 60 मिनट में हो गया. 50% कितने मिनट्स में होगा? 50 मिनट्स में होगा? नहीं होगा. So how you have to do the calculation? See here, you have to use the first order reaction kinetics equation. Put करो टाइम पहले 60 का. ओके, और उसके साथ साथ आप सॉल्व करो, आपको रेट कांस्टेंट मिलेगा. वो रेट कांस्टेंट आप यहाँ पे डालो, आपको आपका टाइम मिल जाएगा. ठीक है, 50% मीन्स व्हाट? It is half life. Very good. Okay, any doubts? Yes. Next reaction. If the rate of a reaction is equal to the rate constant, rate of reaction is equal to the rate constant, the order of reaction is. Rate क्या है हमारे? Rate constant से equal है. मतलब क्या हो रहा है यहाँ पे? हमारा order of reaction क्या होगा? Obviously it will be what? Yes, any answers? Rate constant is equal to the rate of reaction. R is equal to K. तो यहाँ पे जो concentration terms है उनपे क्या है? 0 है. मतलब ऑर्डर का रिएक्शन की ऑर्डर क्या है हमारी? ठीक है, order of reaction must be 0. Then next problem, what is happening? For a reaction A plus B, okay, product has been formed. It is observed that, what is observed? That on boiling, the initial concentration of A only, the rate of reaction becomes double. On doubling the initial concentration of A, 2A किया, रेट का रिएक्शन कितना? रेट ऑफ रिएक्शन भी क्या हो गया? डबल हो गया. Okay. On doubling the initial concentration of both A and B, there is change of factor 8. So same question आया है, देखो क्या होगा हमारा आंसर? सेम क्वेश्चन है, ठीक है, लेकिन पूछने का तरीका डिफरेंट. ठीक है, 2A और 2R कर दिया हम लोगों ने. ठीक है, यहाँ पे मैं करती हूँ 2A और 2R. 2A कर दिया और 2B कर दिया. हमारा रेट कितना बढ़ रह गया? 8 टाइम्स. So what will be the rate of this given reaction? So last time मैंने इक्वेशन फॉर्म किए थे, इस टाइम मैंने अलग टाइप से आपको दिखाया. देखो आंसर, रेट क्या होगा रिएक्शन का? m a raised to m into b raised to m. So 2a किया 2r था, 2a 2b किया 8r था. ठीक है, from 1 2 and 3 m is equal to 1 and n is equal to 2. So here the rate of the reaction will be what? 1 plus 2, that is third order reaction. हमको यहाँ पे ऑर्डर नहीं पूछी थी, हमको सिर्फ रेट पूछा था. तो क्या आएगा हमारा आंसर? ए ऑप्शन. ओके, एनी डाउट इन दिस? हम लोगों ने जो आगे का प्रॉब्लम सॉल्व किया ना यहाँ पे, हाँ ये देखो, ये नहीं हो गया। हाँ ये प्रॉब्लम, इस तरह का ही वो प्रॉब्लम है। ठीक है, जब रेट बढ़ता है तो 2 टाइम्स क्यों बढ़ रहा है, वो 2a की ए करने की वजह से 2r हो गया। जब 2a भी कर दिया और 2b भी कर दिया, दोनों का कॉन्सेंट्रेशन ए और बी बोथ कॉन्सेंट्रेशन इफ वी बिकम वी केम वी डू डबल ना, what will happen to the rate, it is becoming 8 times. So what will be the rate of reaction? So like this way we can say that the rate of the reaction will be like this way, a to b. Okay. Any doubt in this? Okay, so thank you so much for joining in. If you have any doubts, you can tell me. Yes, so thank you so much for joining. If you have any doubts, you can ask. Okay, no doubts. Okay. Thank you so much for joining. Yes. Tomorrow is your test, right? All the best for the test. Prepare well.